Okay, let us discuss this problem 1.193. Let me first make the diagram for this. So I have a horizontal table. So let us say this is a horizontal table. And this object, so there is an object of mass m. And this goes something like this. So motion of the object is given to you, and initially this is attached by a thread. So this is the thread. So let us make the thread a solid line, and this thread is being being pulled from the bottom. With a constant force F, and F is constant. So this is a constant force F. Now let me read the question. This is a light non-stable thread. This is 1.193. So a small object of mass m tied to a non-stretchable thread over a smooth horizontal plane. So this plane is smooth, mu is equals to 0. This object of mass m is tied through a thread. So this is the thread, and this one thread is here. It passes through a hole in the table. So let me read. A small radius of the object is capital R. Initially the radius is R0, so t is equals to 0. R is given R0. So initially this is the length. This length is R0. Now question says the other end of the thread is being drawn into a hole at O with a constant velocity. So there is a hole in the table, and this thread passes through that hole, and this thread is basically pulled downward with a constant velocity. So this is pulled with a constant velocity. Force is not constant. Velocity is constant. So this is pulled through a constant velocity. Now force is not constant. Velocity is constant. That is given in the problem. So this force is basically not constant. It's variable. It should be variable. Now it is given in the question velocity is constant. Now it says find the thread tension as a function of R. So we have to find thread tension as a function of R, and it is also given to you at t is equals to 0, R is equals to R0, and angular velocity is omega naught. So t equals to 0, omega is equals to omega naught. That is given to you. So let us try to analyze the motion first, and then we will discuss. Can anybody try this one? What should be the conjunct? If you see about this point, so what is happening first? Let us try to see. Now this is the mass. So this is initially moving this side, but the length is pulled, so the radius will become smaller and smaller. So initial radius is R0. After some time, radius will decrease from R0, and after some time, this will clearly goes in something like this, and finally it will fall into this point, because at that point of time, radius will be 0. Are you getting? So you see, what is the thing that is conserved in this case? Anybody give me the answer? Yeah, in this case angular momentum is conserved. If you see this axis, about this axis, the tension that is acting in this thread, so there is a tension in this thread, this passes through this point, and this force also passes through this point. So I can say about this axis, so let me make this one. About this axis, so this is my axis. About this axis, angular momentum will be conserved. So let us call this as a OO dash. So about OO dash axis, angular momentum is conserved because all the forces passes through OA dash. So I can say OO dash, about OO dash, angular momentum is conserved. So about OO dash, angular momentum is conserved. Are you getting? So about O dash, angular momentum is conserved. So I can apply a, so let us say initially, so this is my table whole. Initially this is moving at radius r0 and somebody is pulling, and this is moving with angular velocity omega naught. So linear velocity will be r naught omega naught. After some time, this has a length only r, and let us say this object is moving with angular velocity omega, and linear velocity will be r into omega, and somebody is pulling from the bottom. So at this point of time, what is the angular momentum? You will see angular momentum can also be written as, because this is moving in a circular path at one instant. So we will have I into omega 1 at this point of time, and omega 1 is simply omega naught. So this is omega naught. So initial angular momentum will be I1 into omega naught, and I1 will be mr naught square. So this is simply mr naught square into omega naught. Now at this point of time, let us say this angular momentum is I2 omega 2. This will be I2 into omega 2 is omega, and I2 is mr square, so you will have mr square into omega. So if you equate these two, you will have mr naught square omega naught. This is equals to mr square into omega. So this is my equation 1. Now question says find out the tension, and this is the easiest problem we have. Now at any point of time when this is the motion, I can assume at this instant this is moving in a circular path. So if this is moving in a circular path, tension that is acting inside should be equals to mass into acceleration towards center. So tension is equals to mass into acceleration, that is mv square by r, or m omega square r. Are you getting? So this is the tension you will have. Now you see, if from here you can have omega square r, you can calculate from here omega square r. So mm goes, so what is the omega? Omega is r naught square omega naught by r square. So if I plug this value of omega, I will have mr omega square will be r naught 4 omega naught whole square, and this divided by r to the power 4. Are you getting? Now if you do some more massaging of the equation, you will have tension is m r naught 4, I think you are able to see, omega naught square r cube. So this will be the tension in the thread you will have as a function of r. So if r changes, tension in the thread also changes. Are you getting? I think you are able to understand this one. So you see, in this problem, what is the important point we have? In this problem, only one important point we have, that is the axis passing through the hole, table of the hole, angular momentum will be conserved, because angular momentum about this axis initially is equals to finally, because you see the total forces that is acting on this system, this block, is passes through this axis. Somebody can say about mg. Mg will have, so if you see mg here, that is acting on the table, there is a normal reaction also acting up. So mg and normal reaction basically balancing to each other. So torque of n and mg is already cancelled. So I have to consider only tension, that is the external force in this case. So tension passes through the axis, and the somebody is pulling, that also passes through this axis. So that is also zero, because basically this tension and force F both are same. So this means this is the required tension in the thread. So this means the person has to pull this thread. So person has to pull this thread with a force, and this force should be equals to, so if there is a person that is pulling this thread, so there is a disc is here, and if you are pulling this thread, so you will have force that is equals to tension in the thread. I will assume here is everything is smooth and there is no change in the tension. So if there is no change in the tension, force will be m r naught to the power 4 omega naught whole square by r cube. Are you getting? So this means you have to apply a variable force. If r is big, force is small. If r is small, force is big. So this means initially you have to pull with a smaller force. That is r is high. Initially r is high. So initially you have to apply a smaller force to pull this object inward, but later you have to apply a higher force. So you can draw a diagram. So this will be something like this. So force versus R. If R is a small, very small, then force is very high. So let us say if R is very small, force is very high, and if R is low, force will be very, R is big, force is low. So something like this. Are you getting? So for a smaller R, you will have higher force. For bigger R, you will have lower force. So initially you have to apply a lower force, and then you have to gradually increase the force. So this means to pulling this system, to pull out this system, to pull this system, we have to gradually increase the force. We have to gradually increase the force. Are you getting? So we have to gradually increase the force. Now let's discuss the next problem. This is a quite easy problem, concept of angular momentum itself, and another concept is concept of circular motion. This object is also moving in a circular motion at any point of time, at any instant. So I can write circular motion equation, that is a tension toward the center is equals to mass into acceleration. From there I can find tension, and the tension in the thread is same as the pulling force F, because the hole is smooth. There is no change in the tension at the hole. We'll discuss the next problem.